And it's physics again. We're still talking about energy. We have talked about gravitational potential energy. We've talked about elastic potential energy, the energy stored in a spring system or a rubber band. Let's talk about active energies like kinetic energy, like the energy that a moving object has, like a fast car. As I said to you, when I was at school, I used to spend my time at school flicking people with spring guns and that sort of thing. And when I was at home, instead of doing homework, I would be playing with little cars like this until I became mature and got stuck into my work when I discovered physics and how cool learning could really be. But anyway, little cars like this, they have kinetic energy. What's kinetic energy? It's the energy that something has because it's moving. The more speed it has, the more kinetic energy it has. The more mass it has, the heavier it is, the more kinetic energy it has. How can we work out how much kinetic energy something has? Imagine an object, this car for example, of mass m. It starts off not moving and it accelerates and it reaches speed v by time t. Initially time is 0 and initial speed u is 0. Can we work out how much energy it will gain? Well, we can, because we know that the energy gained is equal to the work done, and the work done is equal to the force times distance. So that's our starting point. Now we can work out force on this object that's accelerating by knowing force equals mass times acceleration. So the work done, which will give us the kinetic energy, is going to be equal to the force, mass times acceleration, times distance. So mass times acceleration times distance. Does that seem a bit weird? S is distance, remember? So kinetic energy will be mass times acceleration times distance. It's accelerating over a certain period of time, it will go a certain distance. Okay, so let's just have a think about what this means in terms of v and t, or at least in terms of v. Well, mass is straightforward enough. How do we define acceleration? Well, it's change in speed per unit time. So it changes from 0 to v, so the change in speed is just v divided by t. That's the acceleration. What about the distance? Now here you have to just think a little bit. Distance is equal to speed times time. But not just any speed, it's average speed times time. So when you think about it, the average speed over the course of this journey isn't 0 and it isn't v. The average speed, if you look at this line here, the average speed will be half of v. So when we say kinetic energy equals mass times acceleration times distance, it'll be mass times v over t times half v times t. Mass times v over t times average speed times t. Now when you look at that, you can see some things are going to cancel out. So t and t are going to cancel out. So you're going to end up with mass times speed times half times speed. So what do we end up with? Kinetic energy equals half mass times speed squared. That is your formula for kinetic energy. If you know the mass and you know the speed, you know how much work needs to be done to get the object to that speed, you know how much kinetic energy it will have at that particular speed. That is your formula. Bear in mind, it's a scalar, it's not a vector. Energy doesn't have direction. Speed, not velocity. Doesn't matter what direction it's going, it's got the same kinetic energy whatever direction it's going in. Okay, there we go, that's kinetic energy.